Okay, ladies and gentlemen, let's continue on with integrating some of our transcendental functions. To do that, let's talk about some trig functions. Now, integration of secant x. We all know the integration of sine x. We all know the integration of cosine x. Secant x, not so much. However, ladies and gentlemen, there are some things in life you just need to memorize. You need to memorize the integration of the 6 basic trig functions. So in this case, the integration of secant x is the natural log of the absolute value of secant x plus tangent x plus c. That can also be found in the notes that are also online. So your short answer here is natural log of secant x plus tan x absolute value plus c. There you go. That is the long and the short of that. Sine to the 7th x dx is a bit of a problem because we have sine, which is no big deal. We can do that. But the 7th power causes us some problems. We also don't have a cosine sitting around anywhere that we could use for u substitution yet. What we could do is we could simply break this into sine to the 6th x times sine x dx. Now I leave that and I say to myself, what does integrate or differentiate to get sine x? The answer, of course, is cosine x. I don't have any of those right now, but I can get them fairly easily. I can change sine to the 6th x into sine squared cubed. Now, with that, I can say, well, wait a minute, sine squared x is the same thing as 1 minus cosine squared x. And cubed times sine x dx. Now, that is one of the trig properties, and those trig properties can be posted online in the notes section as well, but it's going to be a Pythagorean identity. The identities you're going to need are, of course, the reciprocals, which we use all the time, the quotients, which we use all the time, the Pythagoreans, which are used a lot of the time, and in particular, a couple double angle properties. Using some of those are your main properties that you're going to need. Now, unfortunately, we do have to multiply all of this out. So, to solve all this, I would say 1 minus cosine squared x and times 1 minus cosine squared x, 1 minus cosine squared x, and then start foiling it all out. Alternatively, I could simply say, well, wait a minute, what if u equals cosine x, then du equals cosine x dx. Nice thing about that is now all of this turns into, cosine turns into negative sine x dx. Got ahead of myself. So I have a negative that I have to put out front, but now I could change this entire problem into 1 minus u squared cubed du. Now, at this point, you say, well, I still have to FOIL it out. Yes, but now it's a lot less writing. And additionally, it's just a polynomial. So when you FOIL this out, it'll be fairly easy to integrate each of the individual terms because you'll have everything from 1 to negative u to the 6th with everything else in between, and you will simply integrate each of those pieces individually, and when you get your answer, you plug your u back in at the bottom. So that's using an odd power of sine or cosine. The kicker is it has to be an odd power because you have to have the one extra sine or the one extra cosine to split off. If you don't have that, if you have an even power of sine and cosine, it does not work. However, an even power can work if it's a cosecant or a secant because I, in a similar way, can break this up and say, well, if this is what I have for the differentiated u, then what does this need to be? Well, how do I get a cosecant squared? The answer is cotangent squared theta plus 1. So I can replace this with cotangent squared x plus 1, cosecant squared x dx. And now all I have to do is say if u equals cotangent x, du equals negative cosecant squared x dx. And so I simply have the integration of u squared plus 1 du. And of course, at this point, that becomes easy. And 1/3 u cubed plus u plus c, 1/3 parenthesis. Now, what was u? U was cotangent. So cotangent cubed x plus cotangent x plus c. And there's your answer plugged back in. So a couple things that you can do with trig functions using trig properties. One other thing you can do very quickly is if you have the integration of cosine squared x dx. You can, in fact, use a double angle property. Cosine 2 theta equals 2 cosine squared theta minus 1, and you solve it for the cosine squared, which in this sheet calls a power reduction. So you simply replace this with a property. 1/2 plus 1/2 cosine 2 theta integration. In our case, it'd be x. It happens to be theta on my property sheet, so we can leave it x if we so choose. And at this point, we can integrate this. We come up with 1/2 x. Now, when we integrate cosine 2x, you say a equals 2x, dA equals 2 dx. So we need a 1/2, so I get 1/4. Now, cosine goes to sine of 2x and plus c. Now, we of course could leave it here, or we could replace the sine 2x with its double angle property, which is right here, to get back to the regular x's. So 1/2 x plus 1/4. This is replaced by 2 sine x cosine x plus c. That is a double angle property. So, not all evens can't be done, but evens in sines and cosines become more problematic. So, using trig substitution.